Alright, now this has the square root of 4 minus x squared, so this is a trig sum. And this actually also happens to be a sign substitution. So x equals 2 sine theta. Dx is 2 cosine theta. The 4 minus x squared is going to be 4 minus 4 sine squared, which will end up cleaning up to 2 cosine theta. Alright, so plug everything in. On top, the square with the radical stuff is 2 cosine. On the bottom you get x, which is 2 sine. And dx is 2 cosine. Don't forget that d theta. Now these 2's cancel, and you end up with 2 cosine squared theta over sine theta. Now this goes back into just a basic let's simplify and see what we get. Now we have a sign on the bottom. It's not very helpful. Now this is actually one of those integrals that you got to simplify, and it's not really like any of the other ones. So what I tried was rewriting cosine squared as 1 minus sine squared. Again, there's no substitution. You can't let u equal sine because du is cosine. It doesn't take care of the other cosine. So I tried this, and then I distributed the 2. What are we in, x or theta? Alright. Then I noticed that I have one term on the bottom. I can distribute it to both on top. So I can have this turn into 2 over sine minus 2 sine. Well, that's nice because I already know 1 over sine, which is cosecant. I've already done that one. So that's 2 natural log of cosecant theta minus cotangent theta, and minus 2 cosine. Now, just in case, what I recommend on the test, by the way, is just go off into the top, do this, right, just so you don't forget. So it looks like negative sine will go to positive cosine. Plus c, there you go. Moving on. Oh wait, we're not done yet, are we? That's right. Everything is in terms of x. So we got to go back in terms of x. Let's get out our triangle, theta. Now it was x equals sine theta. Oh no, 2 sine theta. All right, 2 sine theta. So what that means is x over 2 is sine theta. Now sine is opposite over adjacent, which lets this down here be 4 minus x squared. Alright, so it's not too bad. We have cosecant, which is 1 over sine, so that's 2 over x. And because sine is opposite over adjacent, so cosecant is opposite over hypotenuse. The cosecant is hypotenuse over opposite. Minus cotangent, which is this. Plus 2 cosine. Now cosine is adjacent over hypotenuse, so we get 4 minus x squared over 2. Now you can do some simplifying, like crossing out the 2's and things like that. That's not really a big deal. Remember, if you get to a point like this, you can stop. You try simplify and then mess up, then we got problems. So. Alright, here we go. Oops, why are you still moving? Okay. Alright, so now this is going to be a partial fraction problem. Now, the bottom has already been factored completely. If it hasn't, you got to make sure you do, or that you do factor it. completely. Now, this is going to be a over x, because the x is a linear term, but the x squared plus 1 is a quadratic term. So, it's going to be bx plus c. So what we're going to do is we're going to multiply by x and then x squared plus 1. And multiply by this denominator here. So on the left-hand side, you just get x plus 1. On the right-hand side, you're going to get a x squared plus 1, and then bx plus c times x. And then go through and simplify and collect like terms. We get ax squared plus a, bx squared plus cx. Alright, so we get a plus b x squared cx plus a. So that gives us a plus b, which has to be 0, gives us cx, oops, sorry, just c. C has to be 1, and a has to be also 1. So that means b is negative 1. Alright, so if we go back up here, it's going to turn into 1 over x plus negative 1x plus 1 over... Alright, so that's what we get so far. This is what we're integrating. Now this one's easy. That's just going to be natural log of x. This one's a little trickier. So what we're going to do is we're going to break this up to be negative 1 over, negative x squared plus 1 plus 1 over x squared plus 1. So what we did was we distributed the the denominator to each one of those numerators. So we got the x over x squared plus 1, and then the 1 over x squared. Because this is tan inverse. This is natural log of x. This is going to have to be done by a substitution. So if you let u equal x squared plus 1, du is 2x dx. The x is up there, the 2 isn't, so we always bring that 2 to the other side. So that's going to give us, I'll actually take the 1/2 outside. Negative 1/2, and now what's inside? Just 1 over u du, okay, which is negative 1/2 natural log of u. Okay, so final answer, natural log of x minus 1/2 natural log of u, but u was x squared plus 1. What was my last term? Oh, tan inverse. Plus tan inverse. Alright. Sorry about that cough. Alright, moving on. I'm going to delete this now. Alright, this one is, there's a couple different ways of doing this. You could do it the very hard way, or you can do it the somewhat easy way. The easy way is to write everything in terms of sines and cosines. So that's 1 over cosine. That's sine over cosine. That's 1 over cosine squared. 1 over cosine. Notice that everything is being divided by some sort of cosine. This is divided by cosine squared. So what I'm going to do is I'm going to multiply by cosine squared, top and bottom. So if you multiply the top by cosine squared, it's going to cancel with this one and this one. So on the top, you're just left with sine. On the bottom, when you multiply the cosine squared through, here you're just going to get a 1. Here, the cosine squared is going to cancel with one of the cosines. It's going to leave another cosine behind. And this is just a basic u sub. So let u equal 1 minus negative cosine du, and then Just blank there. So remember, sine, cosine, negative sine, and negative cosine. Alright. Dx. Okay. So, what do we get? The integral of negative 1 over u du, which is the natural log, negative natural log of u. It's negative natural log of 1 minus cosine plus c. Wait a minute. Wow, I blanked on that one. That is a plus. That is a plus. That is a plus. Sorry about that. I'm not integrating back to negative sign. I am differentiating to the positive sign. Anyways, that's the trick.